Now, welcome again to the second part of the AB calculus test. I wish everyone is fine. As I told you from the beginning, my objective is not only to solve the test problem. Each problem has a topic. My objective is to let you understand the topic itself if you have an open-ended. We solved problem 1 and 2 and 3 and 4 and 5. Okay? Let us discuss each one. I have also my student Ismail. All he is my friend, not only student. Not a student, he's a friend. Ismail, we're going to discuss the first thing, how we derive the exponential functions and integrate exponential function, which is problem number 1. If you remember, Ismail, problem was integration of e to the 2x dx. And I explained for you. Now, I'm going to give you all the rules for this. All the rules for what this. Make believe that, Ismail, the rule you need, look, integration, here's the rule you need. Integration of e to the bx plus c dx. In integration, the exponent has to be always, Ismail, linear. You cannot deal with non-linear exponent for integration. That equal e to the bx. You need it for calculus to allow this function. What's the derivative of this? B plus indefinite integration c, right? This for integration. As example, this we said e to the 2x over 2 plus c. But in my problem was 1 to the 2. And I explained.
So over here c is 2x plus c or no?
No. This c is a constant. This is the rule.
Okay.
But this c, the indefinite integration constant. Okay? Example. Look at 3x. That's what I mean. Plus 2 from 1 to the negative 1 to the 0. Right? Dx. How do you do this integration, Ismail?
First derivative. So you're going to have 3x
E 3x
plus
2. What the derivative of this guy? Only what?
3.
From negative 1 to the 2. And I told you of two pairs of parentheses, right? They start with the top number, right?
So 6 plus 4.
3 times 2, 6, plus 2 is 8, right? And you go then the second, the bottom. E, 3 times negative 1, negative 3 plus 2, negative 1, right? Over what? 3. Then you'll answer E8 minus E negative 1 over 3. Now, the question is, Ismail, how about if you have something like that? Integration of 2, right? To the 3x plus 2. Dx different than what? The exponent, the exponential function.
Aren't you supposed to use a log?
This equal 2, look here, Ismail, 3x plus 2 over what? What's the derivative here?
3.
3 ln the base. Ln what?
Yes.
Ln the base. Ln my what?
Base.
Ln 2. We don't use ln 2 here. Ln e. I don't use ln e because ln e equal what? 1. Because ln e equal 1. We don't use it, right? That's good one, Ismail, right? Then you can do this one. Okay, Ismail. Let us go to the second rule, Ismail, which is what? And then we discuss, make believe you have differentiation about this, right? The second rule we're going to use, Ismail, is what? How to derive it, right? How to derive when you have
When you have e.
E or different base. Y equal E 3x minus, look, I can have anything I want here, right? Y equal 3x squared minus 2. dy, which is the derivative, all what you have to do, 6x plus 2, which is the derivative of which one?
E.
The exponent, right? E 3x squared plus 2x minus 1. Right? Now I should use ln E. I should use here what? But ln E equal what? Because that we ignore it.
So the last step, if this would be ln E, but since ln E
Is equal 1, then we ignore it. To understand, if y equal, right, 2 to sine x, I'm going to use trick, Ismail.
Oh, my best friend.
Cosine x.
Oh my god.
What dy by dx?
Isn't it cosine?
Leave the base, leave this guy alone. Leave me alone. Leave me what? Leave me what?
Alone.
Leave me alone. Derive me. Derive me, please.
Cosine x
Cosine x.
minus sine x.
Y minus sine x, because derivative cosine, Ismail, a
Negative
good
sine.
student. And ln 2. Ln 2, you multiply by ln 2, everything. You can put ln 2 to the front if you want. And this is one of the test problem, if you remember, guys, which is the one has cosine, right? Tan e y equal, example, y equal, he used tan, I'm going to use cotangent in the test. Cotangent e sine, cosine, what, tan.
Whatever you want.
It doesn't matter.
Because I'm not that good with it.
Exactly, no problem, because that I'm doing it for you now. The first step, Ismail, you need equal sign. What derivative of cotan? In parentheses, negative cosecant square. Remember, Ismail, derivative of cotan, negative cosecant, and leave my body, which is what?
Tan.
E tan x alone. Leave me alone. Leave me with my angle. Give me my angle back. The cotan, the cosecant, he said, please give me my angle back. Right? Good? Now what you have to do, you have to derive this guy in the front. This is what we did before, right?
Yeah. Secant square
Derivative of the exponent,
secant square x.
secant square x, and leave me alone, please, leave me alone. E tan x. All what you have to do, guys, now, arrange it, make it what? Nice, right? Make me nice, please. Make me what? The negative comes
To the front.
to the front, right? The e to the front, negative, e tan,
X.
I don't have here, right? I don't have, yeah, right, secant, what I did here, Ismail, I did small mistake. Okay, I'm gonna fix it right away. What my mistake, Ismail?
What did you do? I didn't do mine.
Okay.
You're the one
What we
right.
did, yes, cosine, right?
You forgot to put the cotan in the beginning before the secant? Is that it?
No, we good. Secant, but I need to, my mistakes to do it in different color, right?
Okay.
Tan, secant, right?
Yeah.
Now just fix it. Secant, right? E tan x first. E tan what?
X.
First, right?
Mhm.
What this T, Ismail? Come on, Ismail.
I don't know. I'm not writing it. You're writing it.
Oh my God, you saying I have bad writing?
There you go again.
Some respect, Ismail. A little bit, not too much. Some respect, please, Ismail. Please. Now secant square x, we have it. Cosecant what?
Square x.
Square e to the what? Tan x. Good. Again, I'm gonna repeat this again. The cotan become what? Negative cosecant square, right? And you leave the angle the same. Then you're gonna derive the angle, which is e to the tan x. This here. You leave e tan x. You leave e tan x, and you derive what? The tan becomes secant square. Good? This is another problem. Okay, another problem we did, which is we explained it good, for the concave up, concave down. I'm gonna have a full class for increasing, decreasing, maximum, minimum, maybe with Ismail later on. He will do too many problems for that. We're gonna discuss it through his what? Problem. Now, number 5, the 4, Ismail. Let us go to number 6. We have about 3 minutes, right? Let us go to problem number 6. See what problem number 6. Number 6, he asked me, which of the following are the antiderivative of which one of this function? What's the meaning of antiderivative?
Integration.
The integration, but it's hard to, he want integration of cosine cube x sine x, right?
Yeah.
No, which one? No, give you this. He want the integration of each one. I'm sorry. Give me the eraser. He want me to integrate, to derive each one of these to get what? This. He wants me to derive this guy and this guy and see which one give me what? Cosine cube x, right?
Are you sure you're reading that right?
Yes, yes.
Okay.
I'm gonna tell you why. Yeah, if this is dy by dx, right, for this guy, y, if y equal to see it, I want to do it, just give me the eraser again, I want to do it to leave space for me. I want to explain it for you, just give me a pen, okay, dy, d,
Is, derived.
d over dx,
Is that-
right, this y, right, this is f, right?
Yeah, that's big F is integrated, right?
Yes, if you derive this one, look here,
Yeah.
d, and integrator will get you that one, right?
Yeah, yeah.
Integrator will get you what? That one. You understand? Yeah, when you derive this, you're gonna get what? That. Derive this one. How we derive this one? The first one, I derive it. I explained it before, which is negative cosine 4. I'm gonna derive each one in the board, is better, right?
It's gonna be -4 and negative sine.
But you have right to try it in what? In a good way, which is what? Negative cosine, right? X to the what? 4, right?
Yeah,
Which is
negative sine.
negative, leave the 4, leave cosine x, right?
Yeah,
Derive this one inside,
sine x. Negative.
and 3 here, right?
Yeah,
And what here?
sine x.
Sine
Negative-
x.
Negative sine x.
The negatives comes here. I put the negative here, you see there? Right?
You took the negative out from the cosine and put it out front, but this is.
No, I put it, it's negative, okay. This, another negative here. Negative here. Just erase everything to have space. Okay, give me different color. Different color. Which is negative what? Sine x. Right? Negative and negative, positive, right?
Yeah,
It's gonna be 4, which is exactly the same. 4 cosine cube x, sine x. Then the first one is work with me, right? Now, derive this guy. Okay, give me a different color.
oh, whoops, what did I do?
Yes. Okay, what's the difference of this? 2 sine
X.
cosine x
Sine x over 2.
over 2, right?
Minus
Minus 4 sine x cube, right?
Yeah, cosine x.
Cosine x. Over what?
Over 4.
This does not work, right?
No.
The last one, give me a different color from, I'm gonna do the last one, 3 here. Which is derive it, leave the 4, look here. Everyone, I'm gonna give you a trick, everyone. If your denominator is constant, leave it, don't touch it. I told Ismail this 100 times, man, right? Don't, it's not quotient rule. When you have a constant in the denominator, it's not quotient rule, Ismail. It's not what?
Quotient.
It's not what?
Quotient.
Then derive the top. What derivative of 1, Ismail? 0, right? Negative, right? We have negative. 4 cosine cube x
Times negative sine x.
negative sine x which is
Negatives cancel out, the 4 cancels out.
gonna be negative, negative.
No, it's gonna be positive.
Thank you, Ismail, yes.
Sine cosine.
Thank you, x sine x. Okay, then 1 and 3, right?
Yeah.
Uh,
Well, I would say just 3.
No, this one we can't simplify. Look here, this guy, all of them know, it's not this, okay? This guy, okay, Ismail, okay, thank you guys, and have a nice day.